In this video, we're going to be talking about a single replacement reaction. Pay close attention. This one is the single replacement reaction. You will have a double replacement reaction in the future. So in this case, an element that starts out all by itself on that reactant side will replace another element in a compound. And so it will leave that other element all on its own. So let's go ahead and take a look at an example. So on this first one, we have iron over here all by itself. And then we have copper chloride. We have this compound. When we go through our reaction, all of a sudden that copper that was attached to chloride is now by itself. And then the iron that was on its own is attached to the chloride. So right here, we have just another way of thinking about it. So imagine that this guy right here, he has no friends. He's all on his own. And he comes up to a friend group, and there's two friends, they're really close, they're best friends, and all of a sudden he steals the best friend. So now he's best friends with this guy, and the guy who was the best friend is left on his own. So you can think about that. That's something that happens all the time, and it is exactly what a single replacement reaction is. Let's go ahead and look at another example. In this case, we have copper on its own, and then we have silver, and notice we have one of our polyatomic ions here instead of just an element. It still works in this case. And in this case, the silver will end up on its own, and that copper will attach to our polyatomic ion. Also pay attention, we have some aqueous, AQ, compounds here. So remember that AQ stands for aqueous. It is dissolved in something, and usually that's something, that solvent is water. So you can think of it this way for a general formula. You have A by itself, and then BC, which is your compound. When you go through that reaction, you end up with B by itself, and A and C are together.